Hello engineering friends, welcome to lesson 7 of the CATIA training series in the part design environment. In this lesson, we're going straight to the very important type tab in the whole command to see how we can create a standard M10 countersunk hole with a complete thread. Ready? Let's go.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate. Every line precise and true.
Hello everyone. Last lesson we talked about the hole tool. As you may recall, I mentioned this tool setting window has three main sections. The first section was for setting up the drill hole itself. The second tab is name typed. In this tab, we designed the shape of the hole's opening, which is where the screw head will sit. I'll show you an image now. These images demonstrate that screw heads come in various shapes. If we want the screw head to not stick out from our part surface, we need to create a special area on that surface for the screw head to fit in, making it flush with our part. Here's a picture showing a hexagonal screw head sitting flush with the surface. Sometimes a screw head sticking out can cause injury, or it might not be possible due to design requirements. Allen screws, for example, are designed to sit below the surface. Let's imagine we have a shape like this. I want to make a threaded hole on its top surface. My screw head is cone shaped. My screw is an M10 size. First I click on the hole command. Then I click on the top surface of the part. I set the hole's basic parameters in the extensions section. Notice that the hole diameter is 10. Remember, for an M10 screw, the actual drilled hole diameter should be slightly less than 10. To create the shape for the screw head, I go to the Type tab. At the top, you'll see the word Simple. We use this option when we don't want to create any special shape for the screw head on our surface. But since my screw head is conical, I want to create its matching cavity within the surface. I click the V symbol next to Simple. A drop-down menu appears. This menu lists various types of screw heads. If I click on any of them, it will be accurately shown in the preview picture. In my case, my conical screw head matches the countersunk option. Below this option, you'll see Hole Standard. This option is currently set to No Standard. I click the V symbol next to this option. Nothing is visible for now. In the Parameters section, you'll find an option called Mode. It's currently set to Depth and Angle. If you look at the preview image, you'll see it shows the depth of the head part of the hole and its conical angle. I click the V symbol next to it. Two other modes are also available. I click on the second mode, depth and diameter. You'll see that the preview now shows the top diameter of the conical cavity and its depth. The two boxes below it also changed to match these options. Right now the depth is 5 mm and the screw head diameter is 20 mm. It might seem like a 20 mm for a conical head diameter is too big for an M10 screw. I'll show you a picture proving that 20 is the correct number. With these settings, we now click on the Thread Definition tab. The Thread Settings page opens. If you look at the thread-related parameters at the bottom, they are currently inactive. To activate them, first check the box next to the Threaded option. The first option for setting thread parameters is Type. It's currently set to No Standard. Our thread was M10. I click the V symbol next to it. You'll see two metric standards, fine pitch, a small thread spacing, and coarse pitch, large thread spacing. I select first option. The warning says that there is no standard screw with a 10 mm hole. I click OK on the warning message that appears. Below Type, you'll see Thread Description. It's currently set to M1. I click the V symbol. The list of available screws opens. I click on M10. Notice the hole diameter automatically changed to 8.376 mm. Note that we had previously entered 10 in the Extension tab. I go back to the Extension tab. You see that the diameter is now 8.376 mm and is inactive. I return to the Thread tab. The third option shows the depth of the thread. Currently it shows 10 mm. I double click inside the box next to it. I type 30 in it. The fourth option shows the total hole depth. Currently the number in the box next to this option is 50 mm. I go back to the Extension tab. You'll see that the hole depth we recorded was indeed 50 mm. It's important to remember that the total hole depth should always be greater than the thread depth. The fifth option is the screw pitch. This option is currently inactive. The reason is that we choose a standard screw, so its pitch is already defined. Therefore, this option is grayed out. At the bottom of the window, there are two other options. These two options indicate whether the screw is right-handed or left-handed. I return to the Type tab. You'll see that the conical screw head size remains 20 mm. I click OK. You can see that a countersunk hole was created. The thread itself isn't visually shown in the model. I right-click on Pad 1 in the design tree. I click on Properties. In the Graphic tab, I move Transparency slider to the right. The cuboid becomes semi-transparent. Now we can see inside it. You won't see any actual thread geometry created. It just looks like a simple hole. However, If you look closely at the design tree, the icon for hole 1 is different from a regular hole. I'll draw a non-threaded hole. Compare the icon of hole 1 with the icon of hole 2. There's another way to temporarily visualize threaded holes. We have a toolbar called Analysis. In this toolbar, there's a tool named Tab Thread Analysis. I click on this tool. The Thread Tab Analysis window opens. I click on the Apply button. Look, the thread we created on the first hole is highlighted in pink. The thread specifications are also displayed. Our thread specifications are M10, X30, X1.5. These numbers mean we have a standard M10 metric thread with a thread depth of 30 mm and a pitch of 1.5 mm. If I click close, the visual representation on the screen also disappears. Here, if you paid attention, the hole command handles everything, creating the hole, shaping its head, and adding threads. But in the previous lesson, I mentioned another way to create a hole using the sketcher environment and the pocket command. I click on the top surface of my volume. I enter the sketcher environment. I draw a circle with a diameter of 24 mm. I return to the part environment. I activate the pocket command and create a true hole. Now I want to add a thread to this hole. I can't do this anymore using the hole command. Instead, there's another command called thread tab. This command is located in the Dress Up feature toolbar. I click on it. The thread tab definition window opens. This window has 3 sections. In the first section, you have 3 options: reverse direction, limit face, and lateral face. Also, there are 2 other options, thread and tab. The software automatically activates one of them based on what we select. You can of course change the check mark if needed, but if you make a wrong choice, you'll definitely get an error. On the right side, you'll see a preview image. This image changes based on whether you're working on a hole or a shaft. The adjustable parameters on the preview image are highlighted in yellow. Lateral face is the surface where the thread will be created. I click on the box next to it until it turns blue. I click on the inner cylindrical surface. The software recognizes this as the face. If the lower checkboxes are still on tab, change it to thread. In the limit face option, we must specify the surface where the thread will begin. I click on the top surface of the cuboid. You'll see an orange arrow. This arrow points downwards. If I click on it, the arrow's direction changes. But here we don't have anything above the surface to thread. So I set the arrow direction to point downwards. It also shows the thread height as a number. This height can be adjusted in the first section of the window, under Numerical Definition. You'll find the value in the Thread Depth option. Double-click in the box next to it. Type the number 30. Click the Preview button. You'll see that the thread height shown on the shape changed to 30 mm. In the second section named Bottom Type, you'll see it's currently set to dimension, but there are two other modes. If you click the V symbol next to it, you'll see those two modes. If I select Support Depth mode, the entire height of the hole will be threaded. If I select the Up to Plane mode, I need to select a flat surface for the software. I choose the Support Depth mode. In the first section, the other parameters are exactly like creating a thread using the hole tool. With these current settings and parameters, I click OK. Again, you'll only see a simple hole on the shape. Pay attention to the design tree. Thread 1 is now listed. I click on the Thread Tab Analysis command. I click on the Apply command. You'll see that the software highlights the existing thread with light blue lines. Very good. Today's lesson is finished. Watch the lesson twice. Practice with me the second time. Good luck. Until the next lesson, goodbye.
Let's build the future. Come with me.